by is 50 degrees because we're lowering the temperature from 150 to 100 degrees. So this temperature that we multiply by is 50 degrees Celsius. So we have 50 times 2 is 100 times 72 is 7200 joules equals 7.2 kilojoules. So this first process is 7.2 kilojoules, and maybe we'll box them in black so we can see them. So now let me erase this top board, and we do our second step, and we see that here we have kilojoules per mole, so different units than heat capacity. So we need to get our water, our 72 grams of water, into moles. So we have 72 grams of water, and 1 mole of water has 18 grams of water, and we're multiplying by 40 kilojoules per mole of water. So 72 times 40, get your calculator out, or you can just remember from doing this problem a bunch of times like I have, that you get, what do you get? Oh, so you get 72, it's the easy one. 72 divided by 18 is 4, so that's why I give you 72, it helps things out. 72 divided by 18 is 4, 4 times 140, 160 kilojoules. So just kind of interesting to point out, it takes a lot of energy to go through this vaporization phase, to condense water or to boil water. It takes a lot of energy, no matter which way you're going. A lot of energy has to be released or absorbed. So we're releasing energy when we're condensing water. So this step we have 160 kilojoules, and so the total for 1 and 2, 167.2 kilojoules. So we still have a lot more, some more math to do. The question says removing 230. So let's keep going and do a similar process for our third step. So we have, in this case, again, 72 grams of water, and multiply by our heat capacity, 4 joules per gram Celsius. And in this case, we're starting right here at 100 degrees Celsius, and we're going to 0 degrees Celsius. We want to see how far the energy, heat release going through this whole phase. Excuse me. So we multiply by 100 degrees C. So here, 72 times 4 times 100, so 400 times 72 gives us 28. It's about 28,000, right? But so it's 28,800 joules equals 28.8 kilojoules, and this is for step 3. So 28.8 kilojoules. So again, this is really neat or interesting that to raise water or to lower water from 100 degrees to 0 degrees takes a lot less energy than just condensing water from 100 to 100, just condensing water, doing that phase change from vapor to liquid. And the same can be said to go from 0 degrees Celsius water to 100 degrees takes a lot less energy than it does to actually boil water, to go through that last to actually go through the phase transition. Just kind of neat. It's not something you might have expected. So let's do this fourth step. So I guess before we do that fourth step, let's look at the total energy we have so far. So we have 7.2 and 28.8 gives us 29 plus 7 is 36 plus 160 is 196 kilojoules. And so we're still not really near the 230 that we're removing in the problem. So we're at 196 though. So let's do this last, or not this last step, but the next step, where we do the energy that is released in freezing water. So we take our 72 grams of water, multiply it by 1 mole of water has 18 grams of water, and we multiply that by our enthalpy of fusion, 6 kilojoules per 1 mole of water, and 72 divided by 18 is 4 again. 4 times 6 is 24 kilojoules. So now to go through step 1, 2, 3, and 4, steps 1 through 3 was 196 kilojoules. So 24 more joules is 220 kilojoules total, and that puts us at this phase, this position right here. We had gone through, we had calculated the energy that had to be released, the heat that has to be released to actually freeze the water, and that put us at 0 degrees Celsius in the frozen state, not in the liquid state. And that was removing just 220 kilojoules of heat just to get here. Our problem says that we're removing 230 kilojoules of heat. So we're removing more heat beyond this. So that'll put us somewhere down here, somewhere on this part of the heating curve. And that tells us that the final state of water in this problem will be a solid. So the key to this problem, I think drawing it out helps. Drawing the heating diagram helps. And we're given the heat capacities and the enthalpies, and then really relying on the units to guide you as what you need to multiply the different numbers by. So we know we wanted to end up in units of energy, so joules or kilojoules in each case. So for heat capacity, we had to multiply by grams and a temperature, and so the temperature is the temperature change. So like 150 to 100 degrees would be a 50-degree temperature change. Whereas for our heat capacity, or our enthalpies, we have kilojoules per mole. So all we had to do was multiply by the total number of moles of water, and that wraps up our trilogy of quiz 2 stuff. And hopefully this helps in your understanding of the quiz. These were good problems, and hope it helps.